In this video, I'm going to show you how to take a Wii Nunchuk and interface it with Arduino to control a 3D printed arm. So here we have a bunch of cool things in front of us. It's time to get them working together. The first one we're going to do is the Nintendo Wii Nunchuk. These are super cheap these days. You can get it and the adapter both for under $10 Australian, so that's probably $7, $8 US. They're a dime a dozen, and I highly recommend them for Arduino projects. Now, there are a bunch of libraries available for using the Wii Nunchuk. I recommend this one here. Unfortunately, it's not in the library manager, so you're going to have to download it manually. Only files you need from here are nunchuk.h and demo.ino. All you have to do is navigate on your hard drive, if you're on Windows, to see program files, x86, Arduino, libraries, make a folder called Nunchuk, and note that it doesn't have a C here, it's HUK, and then you drop in the nunchuk.h, and then in the examples, you have their demo file. I'll have a zip file linked in the description below, so you don't need to copy and paste any of the code, you just need to unzip it into that location with all of the directories in the correct structure. Now, before we start, the first thing we've done is to come to our Uno and run out jumper cables from red and black, that's 5 volts and ground, into the rails of a breadboard. It's going to make things a lot easier later on. Now, the main reason I have chosen to use this library is that with the adapter, it's extremely easy to implement. So all I have to do is plug in my Wii connector to the adapter, and you'll notice on one side there's 2 pins, on the other side 3. So just rotate it around until it matches. And we simply plug it in from A2 through to A5. Done, installed. How easy was that? Other thing I'll have in the video description is this sketch here, and it's just a slightly extended version of the one that comes with the library. Basically, we now plug in the Uno, we make sure we've set it to Uno and we've got the correct COM port, and after that, when we upload it, we're going to open the serial monitor. Now, if it's working correctly, it's going to spit out a bunch of these values, and if you watch as I move this around, the numbers on the screen will change as well. So our Joy X and Joy Y is the little thumbstick on top here, and we can see if we press to the left, it goes from minus 127, we press to the right, it goes to positive 128. Now the Y has similar values, up 127, down minus 128. Now ACCX and ACCY are the accelerometers, and that is the motion tracking of the Wii. So as I move those around, you can see that the values change for those two things. It's good to do them one at a time. So if I tilt this one the whole way down to the left, it gets to about minus 211. If I keep going, it starts heading back to 0. And then if I tilt it to the right, it gets to just under 300, 270, 280. So it's important to note those because they might be different for each controller. This is a cheap replica Wii Nunchuk, and the values it spits out using this sketch might be different from other ones like they were with my genuine one. It doesn't really matter which one you use as long as you go through this process first to work out the range of values. Now, the only thing we haven't tested are the 2 buttons. So if we press on those, we can see that button C changes from 0 to 1 and button Z changes from 0 to 1 as well. Now, we are using an Uno here, and that's because it's so easy to plug it in. I have done this with a Mega as well. You basically need to run 3.3 instead of 5 volts into the positive, ground to ground, and then the D and the C go into the matching pins on the Mega. So for me, that's up in the top corner, so that's SCL, SDA. You will need to use pull-up resistors of about 5K. So that was too much hassle for me. Uno works much better, so that's what we're covering in this video. So now that we have this connected and working, it's time to make it do something. So we're going to start with some Neopixels. They are digital, so addressable RGB LEDs, and they come from Adafruit, and they're actually what I use to power my teaching tech sign up here. And there is a video coming on how I made that soon. I'm just waiting until I get a bigger printer so I can do a physical version with timber like that, as well as a 3D printed version as well, to give you as many options to make your own as possible. Now, the Adafruit Neopixel library can be installed from the library manager, and we're going to open the sketch, which is called Strand Test. I think that's the best one to start with and the easiest way to cut corners to get a really nice effect. When we open it up, there's only 2 values we need to change to get going. The first is the pin that you're going to connect it to the Arduino Uno with. I'll stick with 6. And the second is the amount of Neopixels. My strip has 20, so I'm going to put that in there, and now I'm ready to connect it up. Good thing about this is there's only 3 pins. So we have data in, 5 volts and ground. So I'm going to get my jumper wires and I'm going to connect it as such. So I'm going to go from my red into 5 volts. This one here has yellow as ground, so I'm going to plug that in and go to my rail here. And then the last one, as we planned, is the data pin, and that is going to go into pin 6. We're ready to upload the sketch. So it's uploaded and it's going through a demo mode, and this is pretty cool. You'll see that soon it's going to switch to a rainbow one where it slowly fades. That's all that's happening in this one behind me. So all I've done is cut out the bits I don't want, and we're going to do a similar thing now. So back in the sketch, we can see in the loop it calls a number of inbuilt functions, and the one I used for my light I think was rainbow or rainbow cycle, but here we're not going to use any of those. So all I'm going to do is to delete everything except the top one. We're going to use the color wipe one, and if we look underneath we can see it takes a color and then a wait time. So that's what this is here, RGB, 3 colors to mix and then a wait time. So the basis of what we're going to do is to combine the 2 sketches. So we had the demo sketch that I have in the description to take the values from the Nunchuk, and then we have the inbuilt example sketch for the Neopixels, and we're going to take the input values from the Nunchuk and use it to change the colors on the Neopixels. So let's get that done. So I'm going to switch back to my code, and I'm going to take my wire and Nunchuk and I'm going to copy and paste into the Strand Test. So it's going to go in the same type of spot up the top. You can copy the serial begin if you want to debug over the serial port like we were before, but it's not vital. So I'm just going to take the minimum, which is these 3 lines here. We begin the wire, initialize the power for the Uno, and then initialize. They're going inside the setup. There's one really important bit to get from the loop, and that's the if Nunchuk read. So this is the one that polls the Wii Nunchuk and asks for data. We're going to take that and put it at the very start of the loop, and we're going to put our closing bracket before we get confused. And let's fix up the spacing a little bit here as well. One more line to copy. We can see that the commands that we want are all listed here, so each of the inputs. I'm going to start off by having Nunchuk joystick X to control my lights. So I'm going to copy that. Not getting the last bracket, that's from the serial print. I'm going to come back to the Strand Test and I'm going to paste it in. Now this will give me the raw value, but I haven't done anything with it yet. So basically what I'm going to do is make a new variable, int r, and I'm going to make it equal the reading of this. There's only problem, we know that this spits out minus 128 to positive 128, but we're expecting to send 0 to 255. What we're going to do is use the mapping function inbuilt into Arduino. So that's map. It takes 5 arguments, and so far we've given it 1. The first one is the input, so that's the Nunchuk joystick value, and then we tell it what we're expecting to be inputting, and we know that's minus 128 to 128, and the last 2 is what we want it to output. So we want it to output from 0 to 255. Now all we have to do down here is, instead of outputting solid red for our color wipe, we're going to replace it with our variable that we've created on this line here. Let's type in R. So from now on, in the loop, it's going to read the Nunchuk, it's going to map the joystick value from its default through to a 0 to 255, and then it's going to do a color wipe, setting it to that color. The only other thing that I'm going to do is to reduce this time here, because I've got 20 strips and that's fairly long. Now if you're daunted by all these things underneath, we don't actually need them for this sketch. So I'm going to delete those as well, just to clear up space. I think we're ready to upload this one. Okay, so we can see our red has started and we mapped it to joystick X. So now what I'm expecting is when I move to the side, it animates getting dimmer. When I let it go and then I move it back to the right, and it gets brighter. So I've already mapped my first Wii button, but let's do 2. Let's make this interesting. Let's also map the Y to one of the other colors. How about we try green? Good news is we do some copying and pasting here. Only thing we need to add is 1 line with this piece of code. So let's go to the next line, paste it in. This time we're going to have a value called G, and instead of mapping from X, we're going to do it from Y. Last thing we need to do is replace the 0 with G, and therefore we're taking our red from the value of joystick X, our green from the value of joystick Y. Let's upload. Okay, we're done. So we have a mix of red and green, which makes yellow. I get greeny yellow. If I move it down, I get red. If I move it to the left, I get green. If I move it to the right, I get orange. But the real beauty is when I start to mix the colors with my thumbstick, and I can do it in real time, and I can make any analog color I want, and I reckon that's really awesome. But we can go one step further. Let's map one of the buttons to introduce blue, and that's super easy to do as well. So back in our sketch, we're going to copy our line. We're going to paste it in and make a couple of changes. So this time our variable is going to be called blue, and instead of mapping the joystick X, we're going to come back to our demo sketch and see the button is called Nunchuk underscore button Z. So that's what we'll type in instead. And we know the button ranges between 0 and 1. It's digital, it's either on or off. So that's what we'll put as our input. And once again, we'll tell it to go between 0 and 255. Last thing is to substitute in our B. Let's get rid of that comment since it's no longer accurate, and upload. Okay, we're done uploading. So the first thing we want to see is that when we press the trigger, that the colors change. Excellent. So now we should be able to move it around. At any stage, modify the color a great deal by pressing the blue one to mix it. So we can now get purple instead of yellow. Excellent. I reckon that's an awesome start, but let's move on to something more practical and more complicated. This here is a 3D printed arm that I got off Thingiverse. I'll have a link in the description. I think it's called the EEZBOTarm or the EEZARM bot or something like that. Now there are 3 versions of this, but I prefer version 1 because you can use all the same type of servo for it. So for me, it's less shopping buying the parts. In it at the moment, I have a bunch of cheap knockoff MG90 servos, but for this, they're plenty sufficient. Now there are quite a few pieces to this. You can print them all on one plate, which I did, and I also printed some parts individually that failed. If you're wondering how I made that awesome time lapse, I do have a video on that already, and it's how to set up Octoprint and experimenting with Octolapse. First thing we're going to do is get one servo working in isolation before we take on the complexity of this. See your Neopixels. So the wiring is really straightforward on these. Red gets 5 volts, black goes to brown for ground, and then I'm going to go to pin 9 on the Uno, and that goes to the yellow signal wire. Of course, nothing's happening because we have to revisit Arduino and upload Sketch. You can save this one if you want to, but for me, I'm going to cut straight to opening the example sketch from the servo library, and that comes built in into Arduino. You don't need to worry about installing that. We're going to open Sweep. So we can see up the top, it includes a servo, and then there's a My Servo object. We have a variable to store its position. We attach it, and then we have these 2 loops here that simply move it from one side to the other, 0 to 180, back and forth. Let's upload this sketch and make sure it's working. Okay, that seems to be working well. Time to interface the Nunchuk. Once again, we're going to combine 2 sketches. So the key once again is to copy and paste bits we want from my Nunchuk sketch to get this working. It's going to be pretty similar to last time. So up the top, we're going to include wire and nunchuk.h. We're going to take the 3 lines from the setup and include those here as well. We're going to delete everything in the loop except for one line, and it's the one that we actually need. That is my servo right position. So all we need to do is use this single line every time we want to move the servo. We give it an integer from 0 to 180 and it will move the servo to that position. So we'll come back to our other code. We'll put in what we need to take our readings, remembering the closing bracket. And once again, let's go for joystick X. We've already got our position variable at the top, so we're going to say position equals, and we're going to have to map it once more. So that's our input. We know it goes from -128 to +128. And for a servo, we need between 0 and 180. We'll write the position to it. We might give it a little delay just so it's not going too crazy. And we're ready to upload. All right, we're done uploading. Let's see if it works. Absolutely perfect. Time to scale it up to this big boy here. So to plug it in, I've got a couple of header pins where I've moved the black plastic to the center, and I'm going to plug that into the positive and negative. And then I've got an extra jumper wire which I've bent to the side. Connecting it up is now very simple. I just need to plug in this to the rail, and then this one to pin 9. And now I have my first piece of control, which is really cool. I hope you will agree. So I might wire in the other ones exactly the same. I'm going to start on 9 and do 10, 11, 12 for the next 3. All those are wired in. There's only one more thing I'm going to add, and I find that powering 4 servos off the USB is really not enough juice. So I have this modified USB cable here. One end it plugs into the computer, the other end I've cut off and soldered and heat shrink to 2 header pins. So if I plug this into the computer, or a power bank, whatever suits you, I can then insert it into the rail, and I've got approximately twice the juice, which makes moving this around much faster and much more accurate. Let's head back to Arduino and multiply our servo code. So this bit's repetitive but quite straightforward. So we're going to change this to be my servo 1 and position 1, and we're going to update these down the bottom before we forget. And now we can start to duplicate. I'm going to tidy up this a little bit and then copy and paste and simply change them to 2, 3, 4. Let's come down to the setup and do the same thing. And you remember we put them in 9, 10, 11. So that's our first bit of code done. Let's start with something fun by making the claws open and shut by activating the Z trigger. So we're going to copy and paste our code from down the bottom, put it immediately underneath. And we know we don't want it from the joystick X, we want it from button Z, just like last time. The input for that is either a 0 or a 1. And I know from my testing that I don't actually want a full range of 0 to 180, otherwise it opens up far too wide. So I only want from 0 to 80. So let's upload that one. Okay, so we've got 2 problems. They're the same problem twice, and that's that as I do everything, it's in reverse. So if I push to the left here, the robot goes to the right, and the claw is closed until I press the button. And that's actually a really easy fix in Arduino. Let's get that fixed up straight away. All we have to do in the sketch is reverse these 2 numbers. So this one is going to go from 180 to 0. That will invert the way it moves. And this one, instead of going from 0 to 80, it's going to go from 80 to 0. Let's upload that. So immediately we can see the claw opens up, and now when I press the Z key, it works like you would expect. We've got our side to side going lightning fast. Let's do the next 2 axes. So I've just double checked on the robot arm, and it's actually servo 4 that I want to do next. So I'm going to copy and paste my code and set that up. Servo 4 is the forward and back of the robot. I'm going to map that to the joystick. So we'll move this one out here, and we're going to use joystick Y this time. And as we know, it goes from -128 to 128. I've tested this previously too with a servo tester, and I know I want it to go from 45 to 170. That's enough travel, otherwise the whole thing jams up. Fix a typo and let's upload. Excellent, this is working exactly how we want. We can now make it headbutt the table. And we can do quite a bit of damage with this. So there's 1 axis left to do. Whoa. So there's 1 servo left to do on this, and that's what moves it up and down. It might seem like it's happening here, but instead it's just trying to move forward and back. We're going to try and do it so we can tilt this forward and back to get that control. Hopefully that's going to be intuitive. I have a feeling it might actually be a disaster, but a lot of fun. So let's get that done. So this last one is a little bit trickier, but we're going to start by doing what we always do, and that is copying in some code. So the value we're going to take from is accelerometer I, and that command for that was ACCEL capital Y. If you remember when we were looking at the serial monitor, the range of motion was something like -200 to +300. We don't really want to be twisting our wrist that much, so we're going to do something first to constrain the values before we then convert it into the right data range for the servo. So let's make space above what we've already started, and we'll say pos3 to equal constrain. Now this function has 3 arguments. The first is the input, and we're actually going to cut this from here. And the second is the range that we want. So I'm going to do something like -150 to +150. So anything that falls outside that range, so we had -151, it's just going to be capped at -150. If we have -400, it's still going to be capped at -150, and the same goes in the positive direction. Now on the second line, all we need to do is to feed in pos3. Now we know we're expecting -150 to 150, so let's update that. In my previous testing, I found that a pretty good range for this was 180 degrees to 100 degrees. So let's upload this and see how it works. Well, I would if I didn't have typos. I am the typo king. You've got to fix them if you want anything to work. Okay, so that is working quite well. I can tilt it back and forth, and you can see it's controlling that. So if I tilt it up and then reach forward, I can grab something and then come back, tilt to the side, drop it. I think I need to test this with an object. It's something expendable. Got it. Let's go a cube from when I was testing out Octolapse. I've got millions of these. I'm gonna put it down somewhere in reach. I'm gonna hold the base. Okay, I want to tilt it down. I want to tilt it forward slowly. I'm gonna grip. No! Okay, it's out of reach. I have it. I have it. Okay, relax. Lift up. I'm gonna throw it across the room because I can. That was actually awesome. That was super satisfying. Now, one thing I've noticed about this as a side note is you can screw down the base and that'll make it kind of good, but it's a lot more fun to actually leave it like this because you can get it to walk around up until the point where it pulls out all of the cables. But either way, lots of fun. Absolute mayhem. I love it. That's it for this one. Hopefully you learned something new and it gave you some really inspiring ideas for things that you could 3D print and match with Arduino. Thank you so much for watching, and until next time, happy coding and 3D printing.
G'day, it's Michael again. If you liked the video, then please click like. If you want to see more content like this in future, click subscribe and make sure you click on the bell to receive every notification. If you really want to support the channel and see exclusive content, become a patron. Visit my Patreon page. See you next time.